So good afternoon. Today morning we have seen about the introduction regarding cement, and now we are moving towards next step, that is types of cement. So now I'm going to explain what are the different types of cement which commonly used in the construction sector. So first one is ordinary Portland cement. Second one is ordinary rapid hardening cement. Then sulfate resisting cement, Portland slag cement, quick setting cement, low heat cement, Portland Pozzolana cement, air entraining cement, colored cement, that is nothing but white cement, then hydrophobic cement, masonry cement, expansive cement, and finally oil well cement. This ordinary Portland cement is nothing but the purest form of cement where you does not have any type of impurities. So in the ordinary Portland cement, we have three grades, 33, 43 as well as 53. This 33, 43 and 53 represents the strength after 28 days of curing. And next is rapid hardening cement. Rapid hardening, the name itself says that it can able to get the strength within a short period of time. This type of cement will be most probably used where the early removal of foam is required. Rapid hardening cement develops the strength within 3 days, where the same strength can be attained in the case of ordinary Portland cement is 7 days. So the main reason for early strength development of rapid hardening cement is due to higher proportion of dicalcium silicate as well as tricalcium silicates. In the morning class, I have represented the Box common and how it is going to influence the mechanical performance of the concrete. Similarly, the similar chart was given over here. So here the C2S and C3S is responsible for early development of strength, whereas C3A is responsible for setting and C4AF is responsible for higher resistance against sulfate attacks. So if you need high strength or else if you need to attain strength at very early age, you need to boost the proportion of C3S as well as C2 content in the cement. And as it said, where you need early removal of foam work, that places you can able to use this rapid hardening cement. In addition to which, you can use this type of cement for repair works. And apart from that, most of the prefabricated concrete yards are using this rapid hardening cement, where within a day they used to demold the concrete from the mold. For that purposes, they use rapid hardening cement. And also in cold weather regions also, where you have extreme chillness or extreme moisture, in that condition also this rapid hardening cement is a quite suitable material for attaining the strength and to enhance the resistance against frost damage. And the next type of cement is sulfate resisting cement. And this type of cement reacts with, generally this type of cement are used for enhancing the resistance against alternating wetting and drying conditions. So most probably the region where you have alternate snowfall as well as summer simultaneously happening, that conditions this type of cement is highly used. The main purpose is the sulfates. Generally, sulfates reacts with the calcium or hydroxide presence in the inside the cement and forms ettringite. And ettringites generally will tends to increases the volume by 227 times. So because of which the cracking of concrete will be taken place. So to resist the sulfate attack inside the concrete, so people have used this type of cement to enhance the resistance against the sulfates. So most probably this type of cements are used in offshore areas also, where your structure is being subjected to alternate wetting and drying conditions, as well as where the presence of salts from the marine will tends to attack. Okay. And next, and as I said previously, okay, this type of sulfate resisting cement was mainly used in the case of offshore areas and where the soil which is rich in sulfate salts. So that type of area where concrete had a direct exposure with sulfates may lead to deterioration. So that in such conditions, sulfate resisting cement is a most suitable choice. Then the concrete made up of the concrete used for the construction of pipes, fabrication of pipes. So that purpose is also we can use sulfate resisting cement. And next type of cement is Portland slag cement, where 40 to up to 50% of your conventional cement, that is ordinary Portland cement, was replaced with slag. Okay. Generally, what is slag? Slag is a byproduct from steel manufacturing unit. So see here I have represented the typical manufacturing process of slag, where iron ore will be fed to the blast. This is the furnace. This is the exhaust chamber. Iron ore will be fed to this chamber, and here temperature will be greater than 1500 or 2000 degrees Celsius, where this iron ore will be melted and converted to some useful steel products. So the residue which is coming out as a waste material will be collected, and this type of material we call it as ground granulated blast furnace slag. And this the slag which is coming out as a byproduct from the steel unit will be called as ground granulated blast furnace slag, where this type of slag will be used as a source material for cement manufacturing process, where nearly 50 to 60% of the cement was replaced with this type of material, this type of slag. So the main advantages of for using this type of material is, so this slag tends to reduces the heat of hydration. So the heat of lowering the heat of hydration will reduces the risk of shrinkage issues. And in addition to which, adding slag will provides higher resistance to chlorides, chloride and sulfate attacks. And next type of cement is quick setting cement. This type of cement is manufactured is just by reducing the gypsum content in the cement. That's it. So generally 2 to 5% of the total binder content will be, I mean total cement content will be used, gypsum will be used, gypsum will be used. So lowering this gypsum content will leads to flash setting, in which the cement can has the higher reactivity with water, and as a result it will set at a faster rate. So mostly this type of cement is used for underwater constructions. And next type of cement is nothing but low heat cement. So here this type of cement will be made by reducing the C3S, that is tricalcium silicate and tricalcium aluminate contents, and increasing the dicalcium silicate content. So automatically the strength attainment will be enhanced and reduces the heat presence inside the mixture. And the main application of low heat cement is mass concreting, such as dam construction. And the next type of cement, we call it as Portland Pozzolana cement, where 40 to 50% of the cement will be replaced with the help of pozzolanic material. That is nothing but fly ash. Fly ash is one of the fly ash. What are pozzolanic material? Why pozzolanic materials are introduced in cement? So cement is one of the high cost consuming material in the concrete. So reducing the cement consumption automatically reduces the cost of production. In addition to which, in comparison with all other materials, cement is one of the highly polluting material. So reducing the dosage of cement will leads to lowering the pollution level in the environment. Okay, then what is pozzolanic material? Pozzolanic material is nothing but a cementitious material which comprises of higher amount of siliceous as well as aluminaceous materials. So it does not have direct binding property. This pozzolanic material will react with the excessive calcium hydroxide present in the cement and forms the additional CSH, that is calcium silicate hydrate, forming the delayed strength formation. So the examples of pozzolanic materials include volcanic ash, pumice, burnt clay, and another best example is fly ash. Fly ash is the one of the commonly used pozzolanic material in India. Why? Fly ash is a byproduct which is obtained from coal-fired thermal power plants. This is the process in which fly ash will be created, where coal will be used for creating heat in the power plant. So with the help of heat, water streams will be created, and with the help of water streams, the turbine will be rotated, and with the help of turbine rotation, electricity will be produced and it will be fed to the transmission line. At the same time, during the production process of the heat, large amount of coal is being burnt. So after burning the coal, some amount of residue, that is the ash deposits, will be present inside the furnace. This ash will be tends to deposit in the furnace, and this ash will be taken off and normally dumped in the open lands. So previously you just see the picture here. I represent the 52-meter height artificial mountain, as well as this 40-meter height artificial mountain. These are all made up of fly ash. That much amount of fly ash is being generated and being dumped in the open lands. being dumping the fly ash in the open lands, instead of dumping in the open lands, it can be used for the production of cement, so that we can contribute something towards the sustainability towards the environment. So that is the reason why people have started using fly ash as one of the replacing material for cement. So the main advantages of using a fly ash in OPC is nothing but, so it reduces the higher heat of hydration and it increases the delayed strength formation. So as the days pass by, you can able to get the higher strength formation. So nowadays PPC, this Portland Pozzolana cement, was used for most structures, hydraulic structures, mass concrete like dams, bridges, piers, foundations, then marine structures, sewage as well as sewage disposal works also. And next type of cement is air entraining cement. So here in the traditional ordinary Portland cement will be there, in addition to which a pigment will be added. Says for example, air entraining agents such as alkali salts, then synthetic detergents, calcium lignosulfates will be added during the manufacturing process of cement. That's it. So additional material we are going to add to the ordinary Portland cement to making this cement as air entraining material. So the material what we are going to provide should be in the dose between 0.025 to 0.1% by weight of cement. If we are providing more agents like this, then automatically we can make the we'll make the concrete weak. So apart from the above said materials, we have some other additives also, such as animal fats, vegetable fats, oils, and their acids also can be used for the development of air entraining cements. So commonly used air entraining agent is air entraining agents is hydrogen peroxide, which is commonly used in the construction sector. So the main advantage of using air entrained cement is it has higher resistance against frost actions. Next is colored agent, colored cement. Similar like air entraining agent cement, air entraining cement. Here also some dosage of pigments, coloring pigments will be added. Say for example, 5 to 10% of the coloring pigment will be added during the manufacturing process of cement. That's it. So automatically the color of the cement will be changed when it is used in the final application. Then hydrophobic cement. Generally, cement cannot be stored for longer duration. So if it's stored for longer duration, the moisture presence in the air tends to react with the cement, and finally it will be formed in the finally cement tends to make this lumps. So as a result, it cannot be used for the construction purpose. So to store the cement for larger days, for higher number of days, people have used some water repellent films such as folic acid and stearic acid to increases the number of storing period. So during the manufacturing process of cement, this folic acid or stearic acid will be used, so that during the blending process, these materials will be mingled to all the particles of the cement, so that a layer of water repellent film will be formed around the cement grains. So which reduces the rate of deterioration of cement during the longer storage periods, especially the region in which you can expect higher amount of rainfall. Higher amount of rainfall such as Assam, Shillong, where these regions will receive plenty of rainfalls in the rainy season. So during this time, normal cement cannot be stored for longer period. So hydrophobic cement is the best choice for this type of locations. Then the next one is masonry cement. Masonry cement is nothing but it is nothing but the conventional type of cement. So the name itself says that it is used only for the masonry purpose. That's it, nothing more than that. So previously lime was used for the masonry purposes, but nowadays people have shifted towards cement because of its easiness and higher efficiency outputs. And next one is expansive cements. In the case of expansive cements, generally concrete, when it reacts with water, it tends to shrink, because of which cracking will be seen at the surface of the concrete, because this was happened because of higher heat of hydration which is generated inside the cement matrix. So during heat of hydration, higher amount of water presence inside the mix will be evaporated, so shrinkage will be happening. So as a result, the concrete has lower tendency to withstand higher loads. So to prevent this type of actions, so expensive medias are added to enhance the resistance against drying shrinkage. So 8 to 20 parts of sulfo-aluminate clinkers are mixed with 100 parts of Portland cement and 15 parts of stabilizer, so that this expansive media will be uniformly mixed throughout the cement. So once you mix this expansive cement with water, so drying shrinkage will not be seen. So in the case of this expansive cement also, you no need to require any skilled labors. Conventional masons is more than